Hey, hello YouTube. How you guys doing? I wanted to give you guys a little bit of an update of what I've been doing. Um, regards to my project for levitation, I've come across a lot of information that suggests that I'm on the right track in terms of the technology or the process for achieving it. The problem is that my understanding of electronics isn't good enough to build the circuit that's necessary to get my other project working. So I've been working on educating myself, um, both on all the basic fundamental electronics principles for resistors and capacitors and amplifiers, transistors, FETs, Darlingtons, the whole schmear. I mean, I'm just with not my area of expertise, and I had a lot to learn. So I've been farting around with a couple other projects as I've been coming, you know, more knowledgeable about inductance and capacitance and the transistors building preamps and amplifier circuits and that kind of thing. I always had in the back of my mind, you take a look at some of the projects I did. The first Bedini circuit where I had the Bedini motor kind of inside out, and I had a coil around it. And inside the coil, I had magnets being drug around inside because I understood that most of the current available is in the center of the heart of the coils. And then I made that accelerator project. I was working with Jeremy, and together we were both kind of working on our own accelerator projects where we were accelerating magnets inside a closed loop. And that project worked out pretty good. You can see that on my channel as well. But I took all of those ideas and what I learned with the transistor stuff. I built this little circuit right here. It's based on FETs. It's got FETs. It's got these FETs, and they're high power FETs, MOSFETs, and I've got them working cross magnetically polarized in these two coils, and essentially what I've got here is a heavy aluminum. I mean, this is a pretty heavy aluminum. It's 4 inches in diameter, and it's 3/4 of an inch thick. Really heavy. It's on a single shaft with two bearings, one on the bottom, one on the top. I've got two pistons that are in each one of these coils, and I'm only using half of the coil in one half of the function and the other half of the coil in the other half of the function. And what I'm doing is I'm addressing half the coil at a time, so I'm pushing and pulling at the same time, but using these Hall sensors, one on each side, 180 electrical degrees off and also 180 mechanical degrees off. So let me show you how this works. Kind of an interesting thing, kind of like the old radial engines, back the airplanes. I used to see John Bedini's big Bedini machine he built with those coils all around the big rotor and stuff, and I thought to myself, geez, if you could just get enough torque, with a Bedini motor, then maybe you can drive something more significant. And so what I did is I kind of had this idea in my head of creating a piston and a crankshaft with enough mass where if you were to expand on the idea, you might be able to generate enough torque. And let me show you what I got going here. Now I'm powering this thing at 25 volts. And you just give this little baby I can play with the timing on it by just moving this timing. I got high voltage here. This thing's making like 78 volts. Well, it was making 78 volts. It's only making 58 right now. I don't know why. Not important, but anyway. Yeah, so it's got, it's got back EMF and it's an AC output. So if you take the output and go through a bridge rectifier, you can probably get I don't know, 40 volts, something like that, DC out. And it's I don't have it. It's on 460 RPMs, 450 something RPMs. But that's it. It's just a simple little. But the thing is that it generates enough torque with just these two coils. A pretty significant amount of torque. A lot more torque than any of the other Bedini motors I've ever made. Clearly. And I realize that if I put 4 coils on it and I drive it 180 degrees on the opposite side with the central bearing, then I would probably generate twice as much torque. Now the coils, they don't get warm or hot. The transistors, they run real cool. The resistors, they run real cool. Everything runs real cool. Even at 25 volts, that's about the peak of what these Hall sensors will take. I've got them stepped down a little bit so that they don't burn out. But the FETs, they'll take like 35 volts, and so you can really push a lot of current through the coils. And if you deregulate it, pull the voltage down, you can turn it way down. You crank it back up, and it'll accelerate back up. It takes a while to accelerate it because it's got so much mass. But anyway, that's it. Kind of a fun little project. Something always in the back of my head. There's the output. I don't have the time base expanded out. It's showing almost 60 volts right now. would have expected a better stream of pulses like that. Well, that's it. AC output, real flat. Very usable. It's got a long way. It can go a long way. Go a long way. A lot higher than what it is right now. $580 RPMs. I mean, that's pretty good. So that's it. Just a fun little project I've been working on as I've been learning, you know, the electronics end of it. My first little set of rods I made, they didn't have any bearings on them. And I could barely get this thing to do like 150 RPMs, 180 RPMs. And then what I did is I made a new set of rods, and I put bearings on the working end of the crank. You can see the bearings on the upper and the lower rod. You know, they both have bearings, and that really freed it up a lot. But that's it. Kind of a fun little kind of almost like an engine, you know, a internal combustion engine kind of a deal where you got a piston going up and down, generating just a lot of torque. But that's it, just a fun little thing. You know, I like to do stuff nobody ever does. And I've never seen anybody build anything like this, so, you know, I just kind of had this thing in the back of my mind, and I kind of had this this deal here going, this circuit board here going, trying to get my other motor going, and I realized that I didn't have my other motor, my, you know, that motor right there. I didn't have that motor wired correctly. I now have it switched so that it's actually a real, what they call a dual phase, and I've got the, instead of it having the coils driven in series, I have separate FETs to each coil with a central ground, so that when I pulse them, each one of the coils gets its own high voltage spike from the FET, and so it goes 330 RPMs, which is 3 times actually faster than what I had the way it was before. I could only get that thing to spin like 110 RPMs, and it was just sad. It's just so heavy. It's just really heavy. All that aluminum. So I've got a new design coming, and I realized I was getting some lens effect in between those plates, and I was hoping to use that lens effect to create a capacitance between the plates. But it's almost like having an electric brake. So I've been fighting the lens effect problem, so I got a new design coming. But at least I got the electronics figured out now, and I can get that working. It's kind of based something on this. So I should have an update on that once I get the new motor built. But anyway, that's my gig. That's the new fun here at the house. So I'll catch you guys in the next update. You all be good. See ya.